Okay, now let's consider algebraic equations where, in fact, we've got lots of sort of stuff going on. How would you actually resolve the equation? So let's go right to some examples and take a look. It turns out it's just a matter of remembering the properties and orders of operations and applying the algebra. 3 times the quantity x plus 5 minus 6x equals 9. Well, how would you resolve this? Well, notice that there's lots of x's swimming around here. So again, the first idea is to get all the x's together and then make sure that there's only x's on that side, moving all the constant terms over. So the very first step, of course, is to always start with the parentheses. That's the order of operation. So let's distribute that 3. And when we do that, we see 3x plus 3 times 5, which is 15, minus 6x equals 9. Well, now I can actually combine these two things. These are like terms. If I take 3x and I subtract off 6x's, I'm left with negative 3x plus the 15 equals 9. Well, great. Now I want to get rid of that non-x term. So what I'll do is I'll just subtract off 15 from both sides so that it keeps the balance. And what do I see? Here I see, on this side, these cancel. I'm left with just minus 3x. And here I'm left with minus 6. 9 minus 15 is negative 6. Now, what would you do next? Well, what you would do next is you would divide both sides by the coefficient, which in this case is negative 3. And if you do that, we see that, in fact, here these things cancel. I'm left with x alone. And here, a negative divided by a negative is a positive. 6 divided by 3 is 2. We get the answer. Let's see if that makes sense. Let's plug back into the really complicated original expression, see if it yields 9. Putting a 2 in for x, I see 2 plus 5. So that's actually 7. 7 times 3 is 21. And if you take 21 and subtract 12, what do you get? You get 9. So in fact, this actually does check. Now I want to return to the penultimate step here, right at this point, and notice that there's a different way you can actually think about this. It's equivalent. So let me just pick up the action right here. Let's pretend that we sort of go backwards in time. Because not only can you divide both sides, but you could also multiply both sides. Now, what would I multiply both sides by in order to get rid of that? Well, what I would do is I would just multiply both sides by the reciprocal of the coefficient, which in this case would be minus 1 over 3. And I have to do it this side too, multiply by minus 1 over 3. If you look at it, it really is the same thing. Do you see the minus over 3? Minus over 3? It's the same move, but here I'm thinking about it multiplicatively rather than as a division. They're equivalent, but sometimes actually it's handy to think this way. Now notice there's a cancellation. The 3's go away. Negative times a negative is a positive. And so we are left with x on this side alone. And negative times a negative is still a positive, and 6 divided by 3 still is 2, so we get the same answer, but now looked at in a slightly different way. Let's try one more equation together. 2 times the quantity a minus 3 plus 3 times the quantity 5 minus 3a, all minus 2 equals 0. Again, a really complicated circumstance, but we always begin by removing parentheses. That is always the place to start. So I'm going to distribute and see what we get. So here I get a 2a minus 6. Here I get a plus 15 minus 9a minus 2 equals 0. I combine the like terms, so I see a 2a, but I'm subtracting off 9a. That leaves me with a net of minus 7a. And then I've got all these numbers running around. Let's see if we can make some sense out of this. Here I have a minus 6 plus 15 minus 2. Well, minus 6 and minus 2 is minus 8. 15 minus 8 is 7. Ah, great. So now I've got a simple thing. I want to get rid of the constant term to the other side, so I'll subtract it from both sides to keep things equal. When I do that, I see minus 7a equals minus 7. And now I can divide by the coefficient of minus 7 on both sides. And I see, remarkably, that a seems to equal 1. Minus 7 over minus 7. Let's check and see if that's okay. If you put a 1 in here, this produces 1 minus 3. That's a negative 2. Negative 2 times 2 is negative 4. Here, if I put in a 1 for a, I see 5 minus 3, which is a 2. 2 times 3 is a plus 6. And then I have a minus 2. But notice that a minus 4 plus 6 is a plus 2. Minus 2 does equal 0. It checks. So in fact, this is the right answer. The great thing about these algebraic equations is that you know if your answer is right because all you've got to do is plug back in and check. There is absolutely never a moment where you could leave things to chance. You can always go back and carefully see if your answer is right. And if it's not, you can go back and see if you can find your mistake. Congratulations on solving your first algebraic equations.